Dear students, in this lecture we are going to discuss or prove that violet light bends the most. So let us first draw a prism. It is a prism. When white light falls into it like this, what happens? We know that light gets dispersed like this. It certainly go like this. So all the 7 colors forms over here. So we need to prove that violet light means this light bends the most and red light bends the least. Okay, in between all the light will be there. All the colors which are in WebGor will present between red and violet. So we need to prove that violet bends the most. So let us start our analysis. So we can say that in WebGor, the wavelength of violet is least, so it has less wavelength, and that of red is maximum, means it has more wavelength. Okay, so first fact or first point is this. You should keep in mind, for further discussion about this topic. So in further we can write as velocity of ray is equal to nu times lambda, where nu is the frequency and lambda is the wavelength. So for a particular value of lambda, the velocity will have certain value, means for different light, different you can say light present in the white light, all these light will have different value of lambda and hence different value of velocity. So we can say for constant frequency, means frequency is constant. Always keep in mind that whenever light changes its medium, its velocity and wavelength changes, but frequency remains the same. So as frequency is constant, so we can directly write velocity depends on wavelength, and we know that wavelength of violet is lesser than that of red. So wavelength of violet is lesser than wavelength of red. Okay, so first point is this. So we have already mentioned this point. Now the second point which we should go to explain this or to prove this is that about refractive index. You know that formula of refractive index is that mu is equal to speed of light in air or in vacuum by speed of light in medium. Now we know that speed of light in air is fixed, it's constant, we have already discussed that. So means this parameter, this, it will be constant. Okay, so directly we can say that refractive index depends inversely with velocity. This is velocity, the once again light, yes, this is velocity, right? So we can write it as velocity only. Now what we have discussed is that velocity v of violet, where we have discussed, we can 1 minute, we can say it over here that since velocity directly depends on wavelength, so in this point, or we can write it here, that velocity of violet will be less than velocity of red. This is the key point. Okay, now since refractive index depends inversely with velocity, so we can write that velocity of violet is lesser than velocity of red. So about refractive index, what we can say is that refractive index mu of violet will be greater than that of red. Okay, another point we have reached, that refractive index of violet will be greater than that of red. So now what we can conclude from this point is that speed, or you should say refractive index, one second, refractive index of violet is more than refractive index of red. So what we can conclude, that if a medium has more refractive index, what does it mean? It means that light will bend more in that medium, and lesser refractive index means light will bend less. So for violet, refractive index is more, so what we can say, that light will bend more in the case of violet, means bending of violet light will be more than bending of a red light. Okay, so this is the point we need to prove, and now we have proved it. Okay, so this is the point. That's it.